Lighthouse score dropped from 94 to 67 on mobile. A single import from lodash silently added 68 KB to every page. The articles at Next Bundle Analyzer setup uses a custom Webpack plugin. In Next.js 16, Turbopack is the default dev bundler and does not support Webpack Bundle Analyzer. For accurate analysis, ensure you build with Webpack by removing experimental turbo or explicitly setting Webpack config. The analyze equals true environment variable only works with Webpack builds. The article mentions using lodashes or individual packages, but doesn't show the direct path import pattern. For CommonJS libraries like lodash, import the specific file path to bypass barrel issues. Import debounce from lodash/debounce. This avoids the main entry point entirely and bundles only the needed module. The article covers bundle budgets, but doesn't emphasize that budgets must be per page, not global. A 180 KB global budget could hide a single page at 500 KB. Use at Next Bundle Analyzers per page reports to set individual thresholds. Also, budgets should account for gzip compression. The analyzer shows uncompressed sizes, so multiply your target by ~3, e.g., 60 KB gzipped approximately 180 KB uncompressed. Let's break down bundle analysis and performance optimization in Next.js 16, how it works, and the exact mistake behind that failure. Bundle analysis answers one question: what code are my users actually downloading? The primary tool is at Next Bundle Analyzer, which generates interactive tree maps of every page's JavaScript bundle. Each rectangle represents a module. The larger the rectangle, the more bytes it contributes. Tree shaking removes unused exports, but it fails silently in 3 common scenarios. First, CommonJS modules. Lodash is CommonJS, so named imports compile to require and bundle everything. Second, barrel files that re-export many modules force the bundler to trace everything. Third, packages without side effects. False prevent tree shaking entirely. A barrel file at components/index. TS that re-exports 47 components forces the bundler to trace all 47 files every time any component is imported. This single pattern can add 100-200 KB to your bundle. Install at Next Bundle Analyzer, add it to your Next. Config, TS and run analyze equals true next build. The output is an HTML file per page showing a tree map where each rectangle is a module. The larger the rectangle, the more bytes it contributes. This configuration adds the Bundle Analyzer plugin when analyze is set to true. It generates static HTML reports for each page, which you can open to inspect the bundle composition. Dynamic imports split your JavaScript so that a module loads only when the component is rendered. In Next.js, Next dynamic wraps React Lazy with SSR control and loading states. Use it for modals, charts, editors, anything not visible on initial load. This example dynamically imports a chart component. Without dynamic import, recharts adds 97 KB to every page's initial bundle. With dynamic import, it's 0 KB until the user navigates to the dashboard. Next.js 16 defaults to Turbopack for development. It's 10x faster. But for production builds, Webpack still produces smaller bundles in complex apps. Always verify production bundle sizes when switching bundlers. This configuration forces Webpack for production builds and customizes split chunks to isolate React into its own vendor chunk. This improves caching. When React updates, only that chunk invalidates. Third-party libraries are the largest source of unintentional bloat. Moment.js at 231 KB should be replaced with the native Intel API. Lodash at 71 KB can often be replaced with a 10-line function. Before installing a library, ask, can I write this in 10 lines of native code? This is a 10-line debounce function with 0 dependencies. It has the same API as lodash, debounce, but adds no bundle size. The 10-line rule: if you can write it in 10 lines, don't install a library. The critical rendering path includes all JavaScript loaded before first contentful paint. Every import in your root layout is critical for every page. Audit these monthly and move non-essential imports to page-specific layouts or dynamic components. This shows the before and after. The before imports toaster in the root layout, adding 28 KB to every page. The after uses a lazy loaded component that only loads when a toast is triggered, keeping the critical path lean. Web fonts are an overlooked performance drag. Next font hosts fonts on the same origin, automatically subsets to needed characters, and adds font display. Swap. Switching from Google Fonts Content Delivery Network to Next Font can reduce LCP by 400 ms. This uses Next Font to load in Tur. It hosts the font on the same origin, subsets to Latin only, and uses font display. Swap. The font is bundled with your CSS, no external network request. This is the same issue we highlighted at the start. Here's exactly why that happened. The team assumed named imports from lodash would tree shake. But lodash is CommonJS, so import debounce from lodash compiled to require lodash and bundled the entire library. The result, 70 KB added to every page. Lighthouse score dropped from 94 to 67. A single named import from lodash, CommonJS, bundled the entire 68 KB library into every page because tree shaking cannot eliminate unused exports from CommonJS modules. The fix was replacing the barrel import with a direct path import debounce from lodash/debounce. This imports only the specific file for debounce, not the entire library. Post-fix, the bundle dropped from 238 KB to 170 KB, back within budget. Importing from a barrel file pulls in every re-exported module. The bundler can't tree shake through the barrel, so you get everything. Always import directly from the specific file. Every import in your root layout, TSX affects the critical render path of every page. That toaster import adds 28 KB to every page, even pages that never show a toast. Move it to a client component that loads only when needed. This is the exact line that caused the incident. Named imports from CommonJS packages do not tree shake. The entire module is bundled regardless of what you import. Always use direct path imports for CommonJS libraries. Dynamic import expects a default export. If your component uses a named export, wrap it equals import /chart, then m equals default m revenue chart. To diagnose bundle bloat, start with analyze equals true next build to generate tree maps. Look for large libraries appearing across multiple pages. Use grep to find where they're imported. Check if the package is ESM by inspecting its package, JSON. Let's run through some common interview questions. Why does import debounce from lodash add 70 KB? Lodash is CommonJS, tree shaking fails. Fix, use lodashes or direct path. How to investigate a suddenly large bundle? Run analyze equals true, check tree map for large modules, grep imports in layout, TSX. When to use dynamic imports? For components not visible on initial load, modals, charts, editors, avoid for above-fold content. And a few frequently asked questions. Does TypeScript affect tree shaking? Yes, if module, CommonJS and tsconfig imports compile to require. Use module, snext. How to check if a package tree shakes. Check for side effects. False in module field in package, JSON. Test with analyze equals true. Can I use Turbopack for production? Not yet unless you verify identical output. Webpack still produces smaller bundles in complex apps. Let's recap the key takeaways. Tree shaking fails with CommonJS, barrel files, missing side effects. Use at Next Bundle Analyzer before every deploy. Dynamic imports cut initial bundle 40–60%. Enforce bundle budgets in CI, 180 KB per page max. Ready to go deeper? Up next, custom cache handlers. Redis, memcached, and distributed caching, then MDX, content management, and draft mode in Next.js, then Next. Config, TS deep dive, all configuration options explained, and pages router to app router migration. Step-by-step guide. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.